Okay, so today's lesson is interpreting and comparing box plots. Our objectives, we're going to interpret single box plots, talk about what they mean and the kinds of questions you might be asked about them, and then how we compare two box plots. Okay, so first objective. We can do the opposite of what we did yesterday. So yesterday, we figured out the key data points from a set of data, and then we used those data points to construct the box plot. Today, we're going to look at the box plot and figure out what those numbers are just from looking at the box plot. Travis, what's the lower extreme?
The lower extreme is 15.
Well, let's look at the bottom of the box plot, not the bottom of the number line.
Oh, sorry.
We want to look
we got started.
here. So what's the lower
18.
extreme? What's that?
18. 17.
17.
I keep looking at the wrong spot.
Okay, let's skip down to the upper extreme next. Hillary, what's the upper extreme?
Upper extreme is 20. Wait, can you draw it?
Yes, it's hard to see that, isn't it?
I think it's like 23.1.
Well, these dashes are each, it's going to be 2, 4, 6. It's about 2. There's actually 1, 2, 3, 4, 5. There's 6 dashes in between. So each one represents kind of close to 2. So we're going to estimate it at about 23.2. Okay, how about the median? Jenna?
20.
Median is 20. Median's right here in the center. It's right above 20, so our median is 20. Lower quartile, Jace.
That would be 18.
Good. That's 18. There's the lower quartile. Upper quartile, Nick. We only have one part left, Nick.
Oh, 22.
Good. Yeah,
Go.
we'll say it's 22. It's close enough to 22. 22. What's that looks weird.
Is the median 20 or 27? It's 20.
What's 27?
It should say 20.
What's 5?
That didn't come out the whole way. Yeah. Oh, I wonder what got erased, but I didn't see it.
Yeah.
Okay.
It looks like a
Two other things that we can find looking at the box plot. We can find the range and the interquartile
Did
range.
you got the numbers all added up and then divided by something?
No?
No,
Jenna,
that's
what's
It's
the
the
range?
biggest number minus the smallest number.
Good. The biggest number minus the smallest number. So our biggest number was, we said, about 23.2 minus our smallest number would give us a range of about, 6.2. The interquartile range is another important set of data that we need to know about. The interquartile range is the distance between the upper quartile and the lower quartile, and it's often abbreviated as the IQR, the interquartile range. Okay? What would the interquartile range be? Jenna?
7.2.
Well, we want to do 22 minus 18. It would be 4. The interquartile range is 4. Here are some other kinds of questions we might be asked. It says, what percent of the data is between 18 and 22? So it's saying, what percent of the data is between here and here? Do you remember yesterday we talked about how this is divided into percents? What do you think, Travis?
Come on. So, 25.
25? Not quite. Jenna?
It's 2 fourths out of 4 fourths, so it would be 50.
It would be 50%. So this is divided into fourths, or each one of these sections is 25%. So this is 25% from here to here, and it's also 25% from here to here. So 25% plus 25% is going to be 50%. So 50% of the data is in between these two numbers. Okay. Number 2 says 75% of the data is less than or equal to what number? So you have to think about how many sections you need to make up 75%.
Ooh. Oh.
Any ideas?
Idea. No. No, no.
How many sections would we need to make up 75%? We need 3 sections. So if 75% of the data is below a certain number, we can't obviously say this number up here because that would be 100%, right? So which line would it be, Jenna?
17,
17 to 18 would only be 25%. We need 75%. Try again.
17 to 22.
All the way to 22. So we would say that 75% of the data, I'm going to use a different color for this, 75% of the data is less than the number 22. We can just say 22 there. Okay, number 3 asks, which half of the data has more variability? The longer the lines are, the more variability, the more spread out the data is. So which half of this is more spread out? Let's cut it in half here. Is it more spread out from 17 to 20, or is it more spread out from 20 to 23.2?
20 and 23.2.
Yeah, the upper half has more variability. We'll say the upper half.
Oh, that was on the piece.
Because it has a range of 3.2, whereas this only is spread out by 3 data points. Okay, number 4 asks, which number represents the 25th percentile? Percentiles we haven't actually talked about yet, but percentiles, each one of these lines is referred to as a percentile. So this line would be the 25th percentile. This line would be the 50th percentile, because it's in the middle, the 75th percentile, and the 100th percentile. And a lot of times when you take standardized tests, it talks about percentiles, and it'll say what percentile you're in. It's just comparing you to all of the other people who took a test. So if you had taken a standardized test and you were in the 50th percentile, it means you were just right about in the middle. About half of the people did better than you, and about half the people did worse than you. If you were in the 25th percentile on a standardized test, that means that 75% of the students did better than you did, and 25% did worse than you did. It's just comparing you to how everybody else did. It's not saying what your score is on the test, right? So if we had a test where almost everybody got a 70%, you could be in the 50th percentile, but your grade would be a C. Okay, so which number represents the 25th percentile? Nick, which number up there represents the 25th
18.
percentile? 18. Good.
Good boy. I'm not a dog. Oh, sorry.
Okay. Okay, now we're going to talk about comparing box plots. So in this set of box plots, we have 2 box plots on the same number line. So when we do that, when we graph 2 box plots on the same number line, we can compare things like their medians and their upper and lower extremes more easily because we can see exactly where they fit numerically. So up on top we have Boston Terriers. On the bottom we have Australian Terriers. Which dog is more likely to have a higher weight? Jace, what do you think?
The Boston Terrier.
The Boston Terrier. Why do you say?
Because there's like a bigger grass thing. It's longer.
Okay, well, longer means that it has more variability, but it doesn't necessarily mean that the weights are bigger.
Oh, it's higher up on the thing.
Yeah, it's further up on the number line. It's hovered above the larger numbers on the number line. Okay, now this one kind of leads into what you were saying. Compare the variability in the weights of the dogs. Let's actually find some of these values to find the variability. So let's find the range for Boston Terriers and then for Australian Terriers. What is the range for a Boston Terrier? Boston Terrier goes from about 22 to 14.5. So what would the range be?
It would be
No, it's 22 minus 14.5.
or 8.5.
It would actually be 7.5 because 22 minus 14 would be 8, but then we're subtracting more. So it's going to be, I'm sorry, 22 minus 15 would be 7, but we're subtracting some more, so it would be 7.5. So the Boston Terrier has a range of 7.5. What about the Australian Terrier? They go from 9 to 16. That one's a little easier. Go ahead, do that one.
Seven.
7. It would just be 7. So the Boston Terrier, and Jace told us this, it looked more spread out to him. The Boston Terrier has slightly more variability than the Australian Terrier in terms of the range. What about if we do the IQR, or the interquartile range? Let's compare those. For the Boston Terrier, the interquartile range is from 20 to 17. So Travis, what's the interquartile range for the Boston Terrier? How far is it from here?
It's from 17 to 20.
So how far is that?
That's 3.
3. So for the Boston Terrier, their interquartile range is 3. How about the Australian Terrier? It's also 3. Good. So we could say the range is a little bit larger for the Boston Terrier, but not really enough for it to be significant. I would probably say that the variability is about the same. It's not exactly the same, the interquartile ranges, but the range is a little off, so I would say the variability is about the same. Okay, now, listen to the next question. Is the median weight for Boston Terriers greater than the weight of all Australian Terriers? So first of all, what is the median weight for the Boston Terrier? Nick, what's the median weight for the Boston Terrier? Remember, the median is the line in the middle of the box plot.
19.
What's that?
19.
19. So the median weight for Boston Terriers is 19. Is that 19 greater than all the weights for Australian Terriers?
Yeah.
Yeah, it is, because the highest weight of an Australian Terrier is 16. So 19 is greater than all the weights that are here for Australian Terriers. So we would say yes.
Yeah.
Okay, next question says a dog weighs 15 pounds.
What?
Is it a Boston Terrier, an Australian Terrier? Could we say, well, it could be either, or could we say it's neither one? What could I say? Travis?
I'm gonna say it's the Australian Terrier.
Okay, well, let's look. Here's 15, right? Let's draw a line up from 15. Could there be an Australian Terrier that weighs 15 pounds?
Yeah. Yeah.
Yeah. Could there be a Boston Terrier that weighs 15 pounds? Yeah. So it could be either. It could be a smaller Boston Terrier or a larger Australian Terrier. So we would say either.
I thought they.
Yeah, both would be fine. It could be both. Okay, any questions about this?
What's the code?
Okay, your homework is an interpreting box plots worksheet, and we have a significant amount of class time to work on this.
So it's your homework that we'll work on?
Yes.
Kind of like yesterday.
Yay.